Welcome to Interactive Storytelling. This sixth set of videos focuses on the fourth and final partaker of interactive storytelling, namely the story world. It is provided by the designer, it runs on a platform, and it exists for the interactor to experience. This time we'll concentrate on characters, which are computer-controlled entities that are represented as avatars and which cohabit the story world with the interactor. But before that, let's take a broader look on the elemental building blocks of the story world. The entities of a story world can be divided into four groups. The first and most noticeable group is the characters. Apart from the interactor's character, the characters are computer-controlled entities that are more or less autonomous. They often have their own goals and possibly could live on without the existence of the interactor. They bring a dramatic dimension into the story world as they can actively assist or resist the interactor's journey. The second group is props, which are objects or tools for interaction. The main difference between characters and props is that props themselves aren't active, but the characters and the interactor can use them to act and to interact in the story world. The third group is events. They can be triggered by the interactor, often unknowingly. They can also be part of some mechanism used to advance a dramatic development within the story world. The last group is scenes, which are the places and locations where the action takes place. This video focuses on the first group, characters. The other three elemental building blocks I will go through in the next video. As I mentioned earlier, Crawford considers interaction a cyclic process of listening, thinking, and speaking. We can broaden this perspective so that listening refers to the character's perception of the world. Likewise, thinking is the decision-making process that is colored by the character's personality and associated with its memory. Finally, speaking refers to the character realizing its decision by acting in the story world. So it wouldn't be that wrong to relabel Crawford's classification to perception, decision-making, and acting, would it? The overall aim is to make the character to act as human-like as possible. At the same time, we should keep the underlying software implementation from getting too complex. Let's start with perception. Basically, the computer-controlled character has an access to all data. It can access all the entities and their attributes and get precise values. This puts them into a different position from the interactor's character and can make them look non-realistic or non-human. As the human perception has limitations, the computer-controlled characters should demonstrate similar features. A traditional way to limit the character's perception is to filter out elements based on physical surroundings. For example, a fog of war limits the perceptible area to a certain radius around the character. Another typical limitation is the use of the layout of the surrounding space so that the character can perceive the elements in the same room. These perceptual filters can vary based on the type. For instance, sounds can be heard from further away, even outside of a room, whereas the visual range is limited by the physical surroundings. A second type of limitation filters out details. If we want to have a fully human perception, this filtering should have several layers, possibly including a simulation of physical sensors and cognitive processes. Usually, this means introducing errors to the character's perception, leading to false beliefs. When thinking about it, error-prone computer-controlled characters is actually a good thing to have. Decisions based on faulty or erroneous perceptions can lead to interesting and surprising, but still believable outcomes. The received perceptions are stored in the character's memory. It could be modeled after the human memory. Let's start with a timeline. The reference point of memory is the current moment of time, now. Before now is the past. And after now is the future. Human memory is typically divided into two broad classes. The short-term or working memory holds the most recent experiences or current thoughts. It's fast to retain and retrieve information, but the amount of information stored in the short-term memory is limited to 5 to 7 items. Moreover, it's fragile, for example to distractions, as you might have noticed numerous times in your life. The long-term memory is the memory of the past. It's much slower than the short-term memory, and retaining and retrieving information takes time and effort. Sleep seems to play a role in strengthening the memory of the day's experiences. A curious phenomenon is that the details are reconstructed and interpreted each time we recover information from the long-term memory. This means that they are subject to distortions and changes, as every memory suffers wear and tear when we recall it. Apart from the short-term and long-term memories, there's also the so-called prospective memory, which is a memory for the future. It allows us to remember to do some activity at a future time and to have the ability to imagine future scenarios. As with perception, the memory of a computer-controlled character could be constructed to mimic the way the human memory works. It could include a short-term memory holding few fleeting pieces of information. The bulk of information is stored to the long-term memory, which requires 3 things. First, it requires accuracy, which refers to how to retrieve relevant information and to measure its trustworthiness. The second requirement is scalability, which refers to how to accommodate the memory for a large number of episodes. For this reason, forgetting might be an important part of the implementation so that older and lesser used information can be cleared to make space for new memories. Third, an autobiographical memory requires efficiency, which refers to how to optimize the storage and recall. This could mean, for instance, omitting details or combining similar memories into a single instance. What is an autobiographical memory, you may ask? Let's look into that. The personal history of a character, including places and moments as well as subjective feelings and goals, forms an autobiographical memory, which is a part of the long-term memory. Autobiographical memories form the human experience, which is based on stories on past experiences, so that new experiences are interpreted in the terms of old stories. The content of the stories depends on how they are told, which is the basis of an individual's remembered self. Dortenhorn recognizes different types of storytelling agents, which can be seen as types of autobiographical memory for the characters. In type 0, the character is always telling the same story. This could be a character in a bar that is meant to be met only once and that has only one story to tell to the interactor. In type 1, the character has a variety of stories from which it chooses one randomly and repeats it exactly. It doesn't have any conversational context, which becomes evident with a closer look. In type 2, the character selects a story that fits the context best and repeats it exactly. To the interactor, this looks more believable than previous types, but it's still easy to spot because the character doesn't listen and respond to the interactor's queries. In type 3, the character is able to interpret the meaning and content of the story and to find a similar story to adapt to the current situation. This means that the character doesn't only tell, but it also listens to stories. In type 4, the character is an autobiographical agent, and we can say that it has a personality. Personality requires more than just memory, so let's turn our attention to different approaches to model the character's personality. A personality model can be used to make a character an individual. We can use the same implementation for every character and avoid making them to appear copies by giving each of them their own personal traits. The most widely spread implementation of a personality model is the classical player attributes of the role-playing game Dungeons & Dragons. In this model, the player's character has 6 attributes, 3 physical and 3 mental, which are usually assigned semi-randomly. The physical attributes are strength, constitution, and dexterity. The mental attributes are intelligence, wisdom, and charisma. In addition, Dungeons & Dragons introduce a popular model of morality or alignment that has 2 orthogonal axes, law, chaos, and good, evil. The law-chaos axis indicates how well the character adheres to rules. The character can be lawful, neutral, or chaotic. The good-evil axis instead refers to the perspective that the character has towards life and other beings. Hence, a character can be lawful good, neutral good, or chaotic good. Next in the axis is neutral. And in the end of the axis is evil. The 6 attributes and the morality differentiate the characters from one another. One can argue that this is a simplified or skewed view to modeling personality. We can of course model the character's personality using existing psychological models for human personalities. One of the well-known is the Big Five model, which is also called the Ocean model or the 5-factor model. It's a taxonomy for personality traits divided into 5 factors. Openness indicates whether the person is imaginative and has creative motivations, or is down to earth and has conventional motivations. Conscientiousness refers to the way the person controls, regulates, and directs their impulses. Extraversion refers to the tendency to seek out stimulation and the company of others. Agreeableness refers to differences in concern with cooperation and social harmony. Neuroticism refers to the tendency to experience or not experience negative emotions. The Big Five model has managed to stand its ground against the test of scientific validity, which could be a good ground for modeling also computer-controlled characters' personality. Whereas the models of Dungeons & Dragons and the Big Five are general models for personality, we can also use models that define a personal emotion towards other characters, objects, or events in the story world. A widely used model of emotion is the Ortony-Clore-Collins or OCC model. The model discerns 3 broad categories, which continues into subcategories on the focus until we have 22 different emotion types arranged in pairs. The first category is related to consequences of events. It includes subcategories on the consequences for other, such as being happy for or resentment and gloating or pity, and consequences for self, such as hope or fear, satisfaction or fears confirmed, relief or disappointment, joy or distress, and gratification or remorse. The second category is related to actions of agents. It includes emotions such as pride or shame, admiration or reproach, and gratitude or anger. The third category is related to aspects of objects, and it includes emotions such as love or hate. Modeling personality of a computer-controlled characters can get too complicated using these 22 emotions, and in practice the models are simplifications. An example of such simplification comes from Virtual Storyteller. Here we have two emotional categories: emotions directed to the character itself and emotions directed to other characters. Each category has 3 pairs of emotions that the character feels, reducing the overall number to 12 from the original 22. This kind of simplification is much easier to implement than the original model. Although a complex model might be more accurate than a simple model, the drawback is that the designer is likely to have difficulties in setting the values or understanding the effects of different uncomplicated dependencies. What makes a character tick is its decision-making process. Based on the input, perceptions, memories, and personal traits, it should come up with a choice. The choice is not only about a noticeable action, but also internal changes within the character, such as setting up or updating its goals or trust in other characters. A broad classification of decision-making methods divides them into optimization and adaptation. In optimization, there's a model or some a priori knowledge that can be used. For example, if our character is a simple barkeeper whose purpose is to serve drinks and give some hints where to go or who to meet, we can have a finite state machine or simple parser figuring out matching patterns in the interactor's utterances. We have a model, and it's only a matter of finding the optimum result. Therefore, optimization is suitable especially when the story world is more linear and under the control of the designer, because the range of different responses is more limited. Adaptation doesn't require a priori knowledge, but tries to adapt to the feedback. It can be taught to find out the underlying dependencies of the variables. Most of the current AI achievements are based on deep neural networks used in problems that offer a clear feedback and make it possible for the algorithm to practice alone for countless repetitions to adapt to the underlying rules. Adaptation would be an ideal way to use in open worlds when a character could adapt to a role and learn how to play it. Regardless of the method, we want to have characters whose behavior looks convincingly human. There's no need for making perfect decisions, but the characters can be, and should be, flawed and error-prone as we humans are. With this, we leave the characters behind and move on to the other 3 elemental building blocks: props, scenes, and events. See you there.